All right, there's a little humor for you to start into gas laws. Boyle's Law is our first podcast, and what's Boyle's Law talk about?
Boyle's law is the relationship between pressure and volume, and specifically that if you change pressure, that volume will change in a inversely proportional fashion.
Inversely proportional. That means what exactly?
Basically, that if pressure goes up, volume goes down.
Oh, that kind of makes sense. So, like if you're squeezing something and it's a gas, you can compress it
Sure.
because it's okay. That
Exactly, like
that
a
makes
balloon.
sense, like a balloon.
Yeah.
Would the opposite then be true? Then if we have the pressure going down, the volume's going to go up.
Yes.
It's pretty simple. That's Boyle's law. The pressure and volume are inversely proportional. If one goes up, the other one will go down. And it's because gases can be compressed that you can do that. An interesting example here is with scuba diving. Did you know, Mr. DiGiacomo, that when scuba divers go below depths of 33 feet, they cannot pass gas?
I did not know that.
I think the pressure outside, the water pressure, is just too much, and it's compressing the gas in your body.
So you're saying human bodies can't produce that much pressure?
No, they can't produce that much
Apparently
pressure
not.
when they break wind. Scuba diving, that's a problem.
Okay.
So here's a container, and the molecules are bouncing around.
And you see as those molecules bounce around, they're going to hit the sides of the container. And what is that called when they hit the sides of the container?
Well, that's actually the pressure. Every time they hit the container, they're putting pressure on it, and that's what pressure is. It's just how often they hit the container. So it makes sense that if the volume goes down, they hit the container more often, and there's more pressure.
Yeah, so increased collisions with the sides of the container mean that the pressure is going to be increased, essentially. And when you decrease the volume, you get increased collisions.
So there you go. Less volume, you get more collisions and more pressure. All right, so here's another example of Boyle's Law.
This is a vacuum chamber, and it's hooked up to a vacuum pump that's going to suck the air out of that container that you see the balloon in.
All right, so we're going to turn it on now. We'll hit play and see what happens when the air gets pulled out of that container. So if it's pulling out air, there's less pressure inside the container
That's correct.
and is pushing on the outside of the balloon less. So why is the balloon getting bigger?
So the air inside the balloon is still the same amount of particles, same amount of air there. So that starts to, it's exerting the same pressure, essentially, which makes the balloon inflate.
So the air inside the balloon didn't get pulled out of the vacuum, and it expanded.
Right, so essentially there's more pressure now inside the balloon than there is outside of the balloon, so it gets bigger.
So there's Boyle's Law. The pressure outside the balloon went down, so the volume of the gas expanded. All right, let's try some practice problems. Here is Boyle's Law, scuba diving. If you've ever been scuba diving, great fun. One thing you might know is that when you're underwater, there's more pressure on you because the deeper you go, the more pressure there is. So if we're scuba diving underwater and we're breathing air in our tank, that air is under pressure. Let's say it's 3 atmospheres. And the volume in your lungs is 9 liters. Your scuba gauge indicates your air supply is low. Oh, you've been down there too long, time to go to the surface. So you want to hold your breath to save air. Is that a good idea? Let's find out. The surface is under standard pressure, so a red flag should go off in your head for what standard pressure means. And we want to know if we hold our breath and raise to the surface where there is lower pressure, what is the final volume of the air in your lungs going to be? Let's just take a quick inventory of all the numbers that we have. We're down under the water and we have an initial pressure, 3 atmospheres. And I have an initial volume that is 9 liters. So just take all the numbers that you have and write them down. Usually there's 2 sets. Here I've got an initial pressure, and then I've got a final pressure, initial volume, final volume. My final pressure at the surface is standard. standard being defined as 1 atmosphere, and I want to know what this number is going to be. What's my final volume? We know Boyle's law says that as my pressure from here to here, pressure is going down. As you raise up to the surface, the pressure is going to go down. So the volume is opposite. The volume should actually increase. So I want to know by how much. I'm going to take my volume and I'm going to use these two pressures to make a ratio. And I'm just going to multiply my volume by that ratio. And how do I know which number to put on top and bottom? Well, you need to know what Boyle's law means. Over here, we said the volume is going to go up. So I need to arrange these two numbers in a manner to make the volume go up. So my first pressure is bigger. So 3 atmospheres over 1 atmosphere will give me a number bigger than 9. So that's what's going to happen. And then since it's a ratio, the atmospheres are going to cancel each other out. This isn't dimensional analysis. We're just kind of multiplying the volume by the ratio of the pressures. And what happens? If the volume in your lungs is 9 times 3 over 1, you're going to get a final volume with two significant figures of 27 liters. So if you hold your breath and come to the surface, your lung volume is going to go from 9 liters to 27 liters. Now what's going to happen to your lungs at 27 liters? Well, the volume is going to get bigger and your lungs are going to burst. Bad idea to hold your breath. Boyle's law in action. Your lungs would pop and you would die. So there's just a quick example of Boyle's law. Let's try one more. If you have gasoline, you have 5.6 liters of gas in a piston. So in your car you put liquid gas in, but it's actually the vapors that burn inside your engine. So the vapors are in there. You got 5.6 liters in a piston and a pressure of 1.5 atmospheres. The piston moves up and down, so we're going to compress it to 4.8 liters. What's the new pressure going to be? Quick inventory. I have a volume here, and that's 5.6 liters. And that volume goes with that pressure, so I'll call both of those 1.5 atmospheres. I've got a second volume of 4.8 liters, and I have a second pressure that is unknown. What's that pressure going to be? So I'm going to take my pressure that I do know, and I'm going to find out how it's going to change. Boyle's law tells me the volume is going down, so the pressure is going to go up. That's what I need to worry about. How do I make the pressure go up? Well, I'm going to take my two volumes and put them in a ratio to make the number get bigger. That means the bigger number goes on top if I want a number bigger than 1. Then my pressure will go up. Liters cancel each other out, and I get my final units will be in atmospheres, so that's good. And the answer here, if you put it in your calculator, you get 1.75 atmospheres. Or, with significant figures, we're going to say 1.8 atmospheres is the final volume of the gas in the piston. So you need to know if you're an engineer, will the engine handle that much pressure when the piston compresses the gas? There's just another quick application of Boyle's law. But you can see how you need to understand what Boyle's law says and how to apply it to put these numbers in a ratio to get your new answer to the system of the problems.